Good day, students. On this clip, we're going to be going over some of finite and infinite geometric series. So let's go ahead and write down the title of the notes. So it's sum of finite and infinite geometric um, sequences. Okay. Remember, when you take the sum of a sequence, whether geometric or arithmetic, is known as a series. Okay. So let's do the first part. We're going to start with finite geometric series. So finite geometric series. All right. So to do this one, it's finite because you're going to have a specified n value, a specified number of terms. It doesn't go on forever. Okay, so let's write down the instructions for the work first, and then we're going to go on after that. Okay, so for this problem, the task is to find Sn for the geometric series, described below. Okay. All right. So let's take a look at the number one. This will give the information that we're going to be using for number one. So for number one, we have A1 equals 15, R equals 2, and we have A5 equals 240. All right. So we're gonna find the sum of the finite geometric series with this information. So first you need to remember is that the formula for a finite geometric series, S of n, is given by a1 minus a1 r to the n divided by 1 minus r. All right. So that's basically the formula that we're going to be using to do these problems. All right. So with that in mind, let's go ahead and solve this problem. All right, so let's list what we know. Make sure we have all the ingredients we need to plug into this formula. So we know that A1, the first term, is 15. The common ratio R is 2. And then N is the terms we are adding. Since the A sub 5 has a subscript of 5, that means N is going to be 5 by default. All right? So let's do it. So we're going to do S5, which is the sum of the first 5 terms of the geometric series with this information, is 15 minus 15 times R, which is 2 to the 5th. Alright? And then we're going to divide that whole business by 1 minus R. So divided by 1 minus R. So it's going to become 15 minus 15. 2 to the 5th is 32. All right, and then divide that by 1 minus 2. 1 minus 2. All right, so let's go ahead and we can plug all this into the calculator and just evaluate it directly. So let's fire up our calculators. So let's do it. So we're gonna have parentheses, calculator into view, parentheses 15 minus 15 times 32 divided by parentheses 1 minus 2, and your final answer is 465. So your sum for this problem is going to be 465. Okay, so go ahead and write that down. So 465. All right, so that's that. All right, let's go ahead and try another example. Number 2. What if we had the given information? A1 is 2, AN is 162, and R is 3. Okay, so we want to find the sum, find Sn. So in this case, we know that A1 is 2. The common ratio is 3. We want to plug it into this formula. This is the formula that we're looking for here, that we're using here. Sn equals A1 minus A1 r to the n divided by 1 minus r. Okay? Divided by 1 minus r. So, let's see. We have A1 and r. What on earth is n, though? What is n? I have no idea what n is. So basically, we do not have enough information to use this formula. So we need to call on the help of the nth term formula, which we did before, which is an equals a1 r to the n minus 1. So this formula will help us find n, and then we can then find what Sn is, okay? So let's plug in the information we have, and then we're going to use it to find what Sn is, okay? All right, so let's see. We're just going to plug in the information we have. We have an, we know that an is 162, right? So we're going to plug in an is 162, equals a1, which is 2, times r is 3 raised to the n minus 1, okay? So we need to get rid of these 2 first, since it's not combined with that. So in order to do that, we're going to divide both sides by 2. So I divide this by 2, divide that by 2. So I'm going to have 81 equals 3 to the n minus 1, because these 2 and these 2 cancel out. Alright? So with that in mind, well, how do we solve this? Well, I need to raise 3 to a certain power to get 81. So 3 to what power gives me 81? I know that 3 to the 1 is 3, 3 to the second is 9, 3 to the third is 27, getting close. 3 to the fourth is 81. Voila, this is the exponential equation I'm looking for, exponential relationship. So that's what I need. So I'm going to express this as a power of 3, because I want it to match this base right here. So I'm going to write 3 to the fourth is equal to 3 to the n minus 1. Alright? So we can see that since the bases match, we know that the exponents have to match also. So we're going to have 4 has to be equal to n minus 1. And to get n by itself, you just add 1, add 1. So 4 plus 1 is 5. N equals 5, right? So n is basically 5. So that's what we need to find the sum, okay? So we're going to plug that into this formula, and we now know what n is. N is basically 5, all right? So let's find the sum. S of 5 is going to be a1, which is 2, minus a1, which is 2 times r to the n, which is 3 to the 5th, since we just found n as 5. Alright, and then we divide that whole business by 1 minus r, or 1 minus 3. Alright, so this is equal to 2 minus 2 times 3 to the 5th power. 3 to the 5th is basically 3 squared times 3 squared, 81 times 3, 243, I'm guessing, divided by negative 2. I'll do that. So 243, we're going to divide that by negative 2. And then we can plug that into our calculator. Okay? Alright, so let's have our calculator do the heavy lifting for us. Let me just verify my computations first to be sure. So 3 to the 5th, I said is 243, and I'm right. Okay, so we're going to have 2 minus 2 times 243. And then we're going to divide that whole business by negative 2. So then parentheses negative 2. And our answer is 242. Okay? So our answer in this case, S sub 5 is 242. Okay, so S sub 5 is 242. Alright? So thanks for paying attention to the first part of the notes. I'm now going to get started with the first part of the classwork, and then we're going to come back. Alright? Alright, welcome back, students. So in this clip, we're going to be going over finite geometric, infinite geometric series. Okay, so let's write down the title. But now we're dealing with infinite, um, infinite geometric series. Okay. All right. So note that when you deal with infinite geometric series, we deal with a special type of situation. Okay. The sum does not always exist. It depends on if the series is convergent or divergent. Okay, so you gotta keep that in mind. All right, so let's write down instructions for the examples we're gonna try out. It says find um, the sum, find the sum of each infinite geometric series if it exists. Okay. So there is a possibility of non-existence here, and we have to keep that in mind. All right, so number one, we have the information a1 equals 5, and the comma ratio is 1/2. Okay, so first thing we have to do is we have to do a test. Okay, we have to do a test to see if it's divergent or not. So the test basically is as follows. The question we're asking ourselves is the radius between 1 and -1? It's the common ratio, sorry, between 1 or -1. Is it between it? The question is if I draw a number line, is 1/2 going to be between these two numbers? We know that 1/2 is definitely in between these numbers, right? So let me just make a sketch a number line for you guys just to give you a visual real quick. If this is -1, and this is 1, this is 0, where is 1/2? 1/2 is right here, right? So 1/2 is between both of them. So since, we have to write a remark here, since 1/2 is between -1 and 1, the series is convergent. That means it's convergent and the sum exists. Okay? And the sum exists. So since the sum exists, that means we have to find it. If the sum didn't exist, then we don't have to find it. Okay, so let's find what it is. Now this problem is qualified for the use of the sum of infinite geometric series formula. Okay, so let's write down the formula first before we apply it. So S infinity is basically given by the first term, a1 over 1 minus r. Okay, so let's see if we have all the information we need. A1 is the first term, which is 5. The comma ratio r is 1/2, so we're going to plug it into this formula. Okay, so S infinity is going to be 5 divided by 1 minus 1/2. All right, so that's going to be 5 divided by 1 minus 1/2 is 1/2. So we have to express the top and the bottom as a fraction. So we're going to write the top as a fraction, 5 over 1 divided by 1 over 2. So we're going to DCF the problem. Since we have a fraction divided by a fraction, we just multiply the top by the reciprocal of the bottom. So 5 over 1 times 2 over 1. Alright, because division is the same thing as multiplying by the reciprocal, okay? So we times these two together, it's going to become 10. Alright, so the S infinity is basically 10. Alright? Okay, let's try another example. Number 2, what if we're given the information? A1 equals 5, and actually let's say we're given a series this time. Let's say we're given a series this time. Okay, so let's say we're given a series defined by 5, 10, 20, and then dot dot dot. Okay, and we want to find S infinity. So for this one, we need to do a test first, right? We need to test for convergence or divergence. So we're going to do the test. All right, so the question is the comma ratio between 1 and -1? Okay, so what's the comma ratio in this problem? The comma ratio R is always the second term divided by the first term, or you can say the third term divided by the second term. It doesn't matter. All right, so in this case, I'm going to use the second term. This is a2 divided by the first term, which is a1. So I'm going to go 10 divided by 5, which is 2. So the question is 2 between 1 and negative 1? Absolutely not. If you draw a number line and take a look at it, 2 is outside that area. Okay, so we have 1, negative 1, negative 1. Let's say this is 0, and that's 1. 2 is 2 in this region right here. No, 2 is somewhere here, right? So 2 is not in this region. So what does that mean? Since 2 is not between negative 1 and 1, the series is divergent. It's divergent. That means it keeps going bigger and bigger forever. That means you can put a number on the sum. Okay, so the series is divergent and the sum does not exist. Does not exist. Okay, so you can't find a sum for this divergent series. It's only convergent series that have sums. Okay. All right, let's take a look at the last example. This one will be expressed in sigma notation. So whatever we have, sigma from n equals 1 to infinity of 3 times 1/3 to the n. Okay? So what's the sum here? First of all, we have to do our test. Is the common ratio between 1 and negative 1? What's the common ratio here? Any term that's been exponentiated, that's the common ratio. So r is 1/3, and 1/3 is between 1 and negative 1, right? That's excellent. So since 1/3 is between negative 1 and 1, the series represented by this sigma notation is convergent, which is excellent, is convergent, and the sum exists. Okay? Alright, so since the sum exists, we have to find it. Okay, so we're going to use the formula S infinity equals A1 over 1 minus R. That's the formula we're using. We already know what R is, right? R is 1/3. But what's A1? In order to get A1, all you just simply do is you take the lower bound, which is 1, and then you plug it into the n value right here, and you work out the whole expression. Okay? So if I plug that in, I'm gonna get my A1 is gonna be 3 times 1/3 raised to what? Instead of 1/3 to the n, I'm going to put the 1 for the n, 1/3 to the first power. Okay? So it's going to be 3 over 1 times 1/3. What's 3 over 1 times 1/3? It's just 3 over 3, which is 1. Alright, so that's A1. Okay, now we have all the ingredients to compute our infinite sum. So S infinity equals A1, which is 1, divided by 1 minus 1/3. So we're going to have 1 divided by 2/3. I need to make the numerator and the denominator both fractions. So 1 over 1 divided by 2 over 3. Since I have a fractional denominator, I will multiply the numerator by the reciprocal of the denominator. And then your final answer is going to be 3 over 2. And that's your result. Okay, so S infinity is basically 3 over 2. Alright, thanks a lot for paying attention to this presentation. Please subscribe to my videos for future updates, and you can also request videos if you want me to make one for you. Hopefully I'll be able to make it. And you can see the collection of my clips at mathgotserved.com. Alright, so have a wonderful day.